Okay, here we go. This will be attempt number 2 at this lab video, so hopefully it'll be a little more focused this time. So basically, the first thing I want to talk about is the first lab procedure that we did, which is where we were finding the rate law for the reaction of the thiosulfate with the hydrochloric acid. And a couple of things I want to talk about here. One, how to write it up exactly, just to make sure that you're okay on that. And then number 2, I want to talk about the mechanism a little bit. All right. So this lab is kind of a standalone. You will do this one separate from the second thing that we did on day 2 of the lab. But just going back to the guide to acceptable lab reports here, you should already have your beginning question, which basically can just be the exact same as the question on the title of the lab. Background information, again, you should have that from the background information the lab itself gives you. And that, okay, so background information would also include all of the pre-lab questions, okay? So the pre-lab questions, pre-lab problems, numbers 1 through 8, okay? Which I went over in the pre-lab video, so that background information should all be taken care of already, but that's where you would put those questions. How will I conduct the investigation? That's your procedure. How will I stay safe? Make sure you include a safety section. The observations and measurements that you made, that should be on, basically you should have a data table like this one right here, where you're measuring the molarity of the concentration of both the thiosulfate and the H3O+, okay? So you're measuring those 2 concentrations, you're measuring your time. You can do the relative rate thing if you want to, the 1 over time. For some students that really helps. You might be able to see it just from the time. You just need to remember that the higher the time, obviously the slower the reaction. So it's kind of opposite of what you might think. Just watch out for that. Okay, so as far as observations and measurements, that's what you would do. Your claims, you need to make 2 claims here. One of the claims you need to make is what is the rate law for the reaction, okay? So basically, the 2 claims are going to be the same as they are in pre-lab problem number 8. One claim will be find the rate law, and the other claim will be propose a mechanism. All right, so you're going to say the rate law for my reaction is, and then you'll write out rate equals K times whatever it is. So you've got to figure out the orders with respect to each of the reactants, and then you can put that into your rate law, okay? Then you're going to propose a mechanism for this reaction. All right, so this is the part that's a little bit tricky, because this is not an easy mechanism. It's not nearly as easy as the mechanism in the pre-lab. So basically, I'm going to give you a couple of hints here on the mechanism, and then I want you to try it as best as you can, okay? And then you're not going to get penalized for doing this wrong. It's just writing a mechanism is not something you're going to have to do on the AP exam. It's not something you're going to have to do on my test tomorrow. I guess today, actually. So you don't need to worry about that, okay? But I do want you to try it because I think it's a good exercise and it helps to think through some of the mechanism things. So basically what you've got 2 reactants, okay? And based on what your rate law ends up being, and I think most people were getting very similar rate laws, then you need to make sure that the slow step in your mechanism matches the rate law, okay? The slow step in the mechanism. So you'll make your steps for your mechanism, and then whichever one of those steps matches your rate law, that would be the one that you label slow. That's got to be your slow step, okay? A couple other things to keep in mind. When you add up all the steps in your mechanism, they need to add up to this overall reaction, okay? Another thing you need to remember, no intermediates are allowed in your rate law, okay, which shouldn't be a problem because you're figuring out your rate law from something else, okay? The other hint that I'm going to give you here that might help you out, and again, this is, I think you're going to struggle with this mechanism, that's okay. All right, just do the best that you can. H3O plus is an acid, okay, because it has 1 more hydrogen than water. All right, so in a typical situation, the reason H3O plus is considered acidic is because it tends to give its hydrogen away to other things. Okay, So there's your hint. That may not happen in the first step, but at some point, probably the fact that H3O plus is an acid, that's going to come into play. Okay. The other thing you need to watch out for here on your mechanism, and you might not think to pay attention to this, you need to make sure that in each of your steps, the charges balance. Okay. Now that doesn't mean that it has to be 0 on both sides, but it does mean that if you have a 2- charge overall on one side of the equation, you need to have a 2- charge overall on the other side of the equation as well. Okay. Your charges just need to balance. So just kind of watch out for that as well. That'll be a good precursor for when we do electrochem. I think you might be able to figure this out. It's, like I said, it's tricky, but just kind of think about it. It's kind of a fun little puzzle. Just see if you can figure it out, okay? So those are your 2 claims that you need to make here. On the what can I claim and what evidence do I have to support the claim, make sure that you include evidence there. How do my ideas and results compare with others and to the literature? I'm more concerned about the literature. So this is where you would actually look up what is the rate law for the reaction. See if you can find that online, okay? I think you should be able to find it. So then the rate law for that reaction, you would compare it to your rate law and see how close it came. Now another thing I want you to talk about here, probably you had to round a little bit, I'm guessing, with your orders. I doubt that, let's say that you had a first order with respect to S2O3 2-, the thiosulfate ion. I doubt that it was exactly first order, right? I doubt that when you doubled the concentration, the rate exactly doubled. I would be very surprised if that happened. So you can still talk about error in that step, the ideas and results compare. You can still talk about error there, even if you got the right rate law, okay? Then the other thing I want you to compare there, so how do my ideas and results compare with others for the rate law, but then also I want you to look up the actual mechanism, see if you can find it. If you can't find it, I may go ahead and show you the mechanism in class on Tuesday before we get started with our next unit, right before you turn in your lab notebooks. So if you can't find it, just leave a little space there and we can go over it on Tuesday. But try and find the mechanism. Now, only do this after you have attempted your own mechanism. And don't change your mechanism after you find it. Because, again, you're not getting penalized for getting the mechanism wrong. I just want you to give it a try. Okay, and then how have my ideas changed? You can talk about what you've learned in this lab. Okay, because I think, how have my ideas changed? You probably didn't have any ideas about the reaction of thiosulfate with hydrochloric acid. So just talk about what you learned there. All right? That's your write-up for the first part of the lab. Or really, this is kind of its own lab. We'll count the other one as its own separate thing. Okay? Then the crystal violet lab here. Let's see. The whole class lab that we did. Just a couple of notes on how to write that up. First, you'd want to take notes on how we did the procedure. So you just, some general, and this is all in your lab notebook, okay? So you would put a separate heading here, crystal violet whole class lab write-up. Write up notes on how the procedure worked, what we did exactly. The Beer's law, absorbance versus concentration data. You would basically take the data that we collected yesterday, which should have something that looks like that, absorbance and concentration, okay, and whatever data you had collected there, I can't remember exactly what it was. Then you would graph that, okay? Now, on the graph, just because this is the way that it's typically done, I want you to put concentration on the x-axis, and I think I told you this in class, in molar, and then absorbance on the right, and don't worry about the units for absorbance. So basically, you're going to end up with a graph, and I think your graph will look fairly linear based on the data that we got the other day. I think I remember that it was pretty good data. So even if it's not completely linear, you're going to make a best fit line that goes through your points. So you want a straight line on this one, okay? So then the purpose of that, the reason that we're doing that is because down here, when we took the data yesterday, when the reaction was actually occurring, we really didn't take concentration versus time data. We took absorbance versus time data, and we did it every 5 seconds, right? So 5, 10, 15, 20. And you wrote down absorbances, not concentrations. Okay, so then what we need really is a concentration versus time so that we can make our concentration versus time graph. So then what you can do, let's say your absorbance is, 1.2. It wasn't that high. I can't remember. It was maybe like 0.4 or something like that at time 5 seconds. Okay. So then what you would do, you would find 0.4 on your graph, okay, and kind of trace across here to where it hits your line, trace down, find out what that concentration is, and that's what you would plug in down here for your concentration, okay? So then you have your concentration and time data, and then you could do these 3 graphs here, okay? First graph, you would just do concentration of the crystal violet versus time. The second one, you would do the natural log of the concentration of crystal violet versus time. And then the third one here, you do 1 over the concentration of the crystal violet versus time. Okay? In theory, and again, I haven't really checked our data to see if it works, but in theory, one of these graphs should give you a straight line. Okay? Let's say that it's the first graph. If this one gives you a straight line, then that means that this is a 0-order reaction. Okay? So that means that neither of the concentrations of the reactants affect the reaction at all. Now, I highly doubt that's what you're going to get here, okay? But that's a possibility. If you get a straight line graph for the natural log of the concentration versus time, then we're talking about a first-order reaction, okay? If you get a straight line graph when you take 1 over the concentration versus time, again, notice the slope is positive here instead, then we're talking about a second order. So you can actually figure out the reaction order based on which of these graphs gives you a straight line. Okay, so that's how you're going to record this part right here, the overall order of the reaction. Okay? Give me 1 second here. Okay. So as far as the overall order of the reaction, that's what we're trying to figure out by our graphs that we do here. Okay? Now, the rate law for the reaction, you're not necessarily going to be able to figure that out just based on the data that we're collecting here. Okay, so don't worry about the rate law for the reaction because you don't need that for anything else that we're calculating anyway. So the rate law, you might get an idea of what the rate law is based on whether it's a 0 order, first order, or second order. Actually, the rate law, if it's a 0 order, is very easy. It's just rate equals k. The rate equals the rate constant. If it's a first order, then you could have the general reaction that you've got here is CV plus OH minus yields CVOH. It's a very simplified version. Crystal violet is a CV. Your 2 reactants there, the CV plus and the OH minus. So if you have a first order reaction, then it's either first order with respect to CV plus and 0 order with respect to OH minus, or vice versa. If you've got a second order, it could be first order with respect to both reactants, or it could be second order with respect to one of the reactants and 0 order with respect to the other. What you're finding out here by doing your graph, I take that back. You're finding the concentration of the crystal violet. I'm sorry. So you're figuring out the order with respect to the crystal violet here. Okay. So again, you can't really find the rate law for the reaction just based on knowing that order because you don't know what the order for the hydroxide is. We would have to figure out some way to measure the concentration of the hydroxide and how that changes over time. Sorry. Still made a mistake in this video even after all that. But okay. So just let me back up here and make sure that you understand what I'm saying. Since we're graphing the concentration of the crystal violet versus time, we're finding the order of the reaction with respect to crystal violet, okay? Which is not necessarily going to help us find the overall rate law. So, but we can find the K for this reaction because all we have to do here is figure out the slope of the lines, okay? So for a 0 order, the slope of the line is going to give you the units. If you get concentration over time, the slope of the line is going to give you molarity per second, right? which is your rate. Well, your rate law for a zero order, rate equals K, because there is no concentration there in the rate law because it's zero order. So rate equals K. That means you can figure out the K just by looking at the slope of the line. Okay. Same thing with the crystal violet here, or sorry, with the first order reaction. The slope here, and I guess I should say it's the rate is negative, or I don't know, negative rate equals negative K. Basically, you need to understand that your K has to be a positive number. You're going to get a negative slope here, so your slope is going to be opposite K. All right, same thing here. Negative K equals the slope. Because of the equations we talked about for first order reactions. And the same thing with second order, except here the slope is just positive K. All right? So whichever one of these you get, and hopefully you get one of them as a straight line, then you can use that to find the K. All right? This right here is the last thing that you need to do for this lab. The rest of it we didn't have time to do because it's all temperature related stuff. Okay? All right, so that's how you write up the second part of the lab. Just use the headings that I gave you there for the second one. You don't need to do any other write-up other than what we just talked about here. Okay? All right, have a good weekend.